Good morning, everyone. Today we are going to be working on our last full lesson before you guys go for spring break. We'll be solving for angles using trig today. So last lesson, you guys were solving for missing side lengths by using trig. So you were given a right triangle, you had a reference angle, and one side length, and you had to find one of the other missing side lengths. So today, you will be able to solve for a missing acute angle in a right triangle when given 2 or 3 side lengths. So we might have something that looks like this. We might have this kind of diagram here. We'll have a right triangle. We'll have the right angle marked. We'll have 2 side lengths at minimum. You could have 3. Most of the time you'll only have 2 labeled for you. And then we'll be trying to find this reference angle instead of a side length, okay? Now, we're still using the idea of SOHCAHTOA, but we need to use a different button on our calculator, so I'm going to show you guys how to do that. Okay, before we get started on the lesson, I want you guys to do this little warm-up here. I want you to evaluate. So the first problem is evaluate. You're just plugging your values into your calculator, okay? And then in number 2, you are solving for x in each diagram. Okay, so first thing is always remember your first step in any of these problems is going to be to make sure your calculator is in degree mode. And as long as nobody used your calculator from the last time that you used it and changed it, it should be fine. But just make sure your calculator's in degree mode. Okay, let me make sure mine is in degree mode. I'm going to click mode. On my menu, degree is highlighted, so we're good. Okay, let's evaluate cosine of 37. Now remember, cosine and sine should always be numbers that are less than 1. Okay, and then there's actually a typo here. I want one of these to be sine of 37. So that should be sine of 37. Okay, so cosine of 37, we plug that in the calculator. It is about 0.799. Tan 37 could be greater than 1, but in this case, it's about 0.754. And sine 37 is about 0.602. Okay, part 2, solving for x in each diagram. Again, here's my little process. Circle your reference angle, label your opposite and whatever your other, well, not necessarily your opposite, but you're just going to label the 2 sides that you have. In this case, I have markings. I have an X on my opposite side, and I know it's my opposite because it is across from my circled angle. And then this would be my adjacent side. We don't have the hypotenuse labeled, so I'm not even going to use it. So now I have SOHCAHTOA, that's our new favorite phrase. So if I have the O and the A, it looks like we're using tangent. Okay, so I'm going to set up tangent, reference angle, equals opposite over adjacent. In order to get rid of this fraction, we multiply both sides by the denominator. Tan 51 equals x. And then we plug that into our calculator. 15 tan 51. And we get x equals about 18.5. Okay. Number 2. Circle your reference angle. I've got my opposite and my hypotenuse in this case. So if I have opposite and hypotenuse, I'm using sine. So we have sine 29 equals 12 over x. Now, since my x is on the bottom for this case, in order to get rid of my denominator, I'm going to multiply both sides by x. So I have x sine 29 equals 12. And then I'm going to divide by sine 29 divide by sine 29. So 12 divided by sine 29 is 24.8. Okay? And that would be our two missing lengths. All right, so now let's get started with using what we call inverse trig ratios to find missing angles. So if you know the sine, cosine, or tangent ratio of an angle, you can use the inverse function to find the measure of the angle. So just really quick, let me throw in an extra page here. Okay, so back to our notes over here. So for each of the examples, we are going to find the missing value of x and round to the nearest tenth. So the process of solving this is still the exact same way. You circle your reference angle and you label the two sides that are labeled. So I'm going to circle my reference angle. X is still my reference angle even though I don't know what it is. And then this would be x's opposite side and this would be x's hypotenuse. So I'm still setting up sine of the angle equals opposite over hypotenuse. And then to undo the sine, I'm going to do sine inverse of my ratio of sides. And then we do second sine, 15 divided by 24, and we get x is about 38.7 degrees. Okay? Let's try another one. Circle your reference angle. 11 represents my hypotenuse. 8 represents my adjacent. So cosine of your reference angle equals adjacent over hypotenuse. I'm going to do the inverse cosine of that ratio. And when I plug that in, I get 43.3 degrees. Okay, so if you want to pause the video and go ahead and try numbers 3, 4, 5, and 6, you can go ahead and do that. I'm going to finish modeling these examples, but if you want to try them on your own and check them, you are more than welcome to. So next one, circle my reference angle. I've got my opposite and my adjacent. So we have tan of x equals my opposite over my adjacent. I need to do tan inverse of that ratio. Second, tan 20 divided by 37, and we get 28.4 degrees. Okay, so next, circle. I've got my hypotenuse and my adjacent. So cosine of x equals 18 over 23. X equals inverse cosine of 18 over 23. And when we plug that in, we get 38.5 degrees. And remember, these are angle measures, so you always want to put your degree value. Okay? All right, so now pause the video, try the last two. Okay, and then we have our answers to our last two. And that's how you can use inverse trig ratios to find missing angles. I'll kind of chat about this a little bit. So basically, what any inverse of a function does is it undoes the property that's happening to the function before. So that's what we call an inverse operation. So for example, if you have something simple like 2x equals 20, okay, the way you would solve for x is to do the inverse operation. So this operation shows multiplication. So my inverse operation would be division. And then you all know, in order to solve this, we just divide both sides by 2, and we get x equals 10. Okay? But if I were to have, let's say, sine of x equals 5 over, let's do 7. Okay? Sine of x equals 5 over 7. I know that what happens here is I have a right triangle, and let's say this is x. My opposite side is 5, and my hypotenuse is 7, okay? But you can't just divide something by sine. Like if you tried to type in 5 over 7 divided by sine in the calculator, it would give you an error because you have to have sine of a number. You can't just have sine. Sine itself doesn't represent anything, so you need to have sine of an angle value, okay? So if you notice, if you're using the graphing calculator that you downloaded, you'll notice above your sine, cosine, and tangent buttons in blue letters, or maybe not necessarily blue, whatever color it is, you could see little letters that say sine to the -1, cosine to the -1, sine -1, cosine -1, and tan -1. If you're using a different calculator, these options are probably somewhere near the trig buttons that you're using. So these are all of the buttons that we're going to use. These are the inverse operations of each trig function. So if I wanted to get x by itself, okay, if I do the sine inverse of sine x, the sine inverse and the sine are opposites of each other. They kind of cancel out. But then I also need to do the sine inverse of 5 over 7. So essentially, when you have something that looks like this, you're always going to have x equals whatever this trig function was, inverse, and then the other side. Okay, and the way you could get to that button in your graphing calculator is hit the second button, sine, and then type in 5 divided by 7. And this time we should be getting a whole number, because remember, this is a degree measure, okay? So we have an angle which measures 45.6 degrees. Okay, so I want you guys to do this mixed review problem set. I'm not going to go over the answers to 7 through 10 in the video, but I will post them online. I will do 16 and 17 with you very quickly so that you can kind of get an idea of how to do those problems, because they are a bit more challenging. So number 16, it's essentially just two triangles that we need to break up and solve one at a time in order to find what they're asking us for. So ultimately, they're asking us to find the measure of angle W, which is this angle right here, okay? Now, in order to do that, which we just did finding missing angles. In order to do that, you would need to have two side lengths in this right triangle. I only have one, okay? I only have one side length. So before I can solve for that, I need to find a missing side in that triangle by using my other triangle, XYZ. Now you'll notice that we have a shared side. It's ZX. So what I'm going to do first is solve for ZX. Solve for ZX using triangle XYZ, because we have enough information for that one. So I'm just going to redraw triangle XYZ. So we have Y, X, this is 15, Z, and this is 25. Okay, so let's go ahead and solve this one. Circle your reference angle. I've got my opposite, and I'm looking for angle for side ZX, so we'll put an X there. And this would be my hypotenuse. So I would have sine. This is finding a side. So our x should not be directly next to the trig function. So we have sine of 25. Again, I know the value of my reference angle, so that's why we're putting the number there, equals my opposite, which is 15, over my hypotenuse, which is x. Multiply both sides by x. X sine 25 equals 15. Then I need to divide by sine 25. And I get x equals, let's see, 15 divided by sine 25 is 35.5. Now, that's not my answer, okay? That was just the length of this side right here is 35.5. But now that that's done, I have enough information. I'm looking for angle W. I've got my adjacent and my opposite. I'm just going to finish this down here. Okay, so again, let me just redraw what we're working with here. we're looking for this angle, and we've got 35.5, which is our opposite, and we have 22, which is our adjacent. Okay, and I'm just going to put X here. So we have tangent of W, okay, because it's angle W, is equal to my opposite over my adjacent. I need to do the tan inverse. And I get the measure of angle W is, let's see, tan inverse 35.5 divided by 22, 58.2 degrees. Okay, so that one is just a two-step process because first you needed to find that missing side in our triangle that we didn't know. Okay, we had to find this missing side first, and then we could use that side to help us find the missing angle. All right, next problem, just a word problem. Okay, a ladder leaning against the wall makes an angle of 75 degrees with the ground. So where the ladder meets the ground is 75 degrees. So let's say this is our little house here. All right, and we've got a ladder leaning against the wall. And then here's the ground. So here is our right triangle. I'm just going to highlight over it so that we could see. Here is our right triangle. This is my right angle. This is 75 degrees, okay, because it makes an angle of 75 degrees with the ground. The foot of the ladder is 6 feet from the base of the wall. So let me just redraw this. So we've got 75. The foot of the ladder is 6 feet from the base of the wall. That would be that bottom length. What is the length of the ladder? This is what we're looking for. So I have reference angle, hypotenuse, adjacent, cosine 75 equals 6 over x. Multiply both sides by x. X cosine 75 equals 6. Divide both sides by cosine 75. And we get x equals 23.2 feet is the length of the ladder. Okay? All right, so now what you're going to do is you're going to finish problems 7 through 10 and check them with the answer key on Classroom. And then after that, you're going to complete and submit the practice sheet, which looks like this and says assignment at the top. There are 3 points each for the top 4, so a total of 12 points, and then the bottom 2 are extra credit, so you can do those as well. And you can just do everything right on this paper, on a separate sheet of paper, scan and submit as a PDF. As always, if you guys have questions, please do not hesitate to reach out.